Welcome to this training program produced in the interest of improving your knowledge and skills with precision measuring instruments. In this program, we're going to look at an instrument which is correctly called a dial test indicator. Sometimes it's just known as a DTI. It may also be referred to as a clock gauge because of its resemblance to an analog type clock. Dial test indicators are used in many applications where measurements need to be taken to assess such things as end float, run out, and wear. They're also used in the setting up of workpieces during machining operations. In this program, we're going to learn the principles of reading and using a metric plunger type instrument that has a reading range of 10 millimeters and is calibrated in 1/100th of a millimeter. Such an instrument is commonly encountered in most general engineering machine shops, during plant and equipment installation procedures, and on many other maintenance or repair-related operations. We begin by first learning about the instrument itself. As the instrument requires a special support, we'll fit it onto this magnetic base set, which we'll discuss in some detail a little later in the program. The most obvious feature of a DTI is its clock face. Within the clock face is a large pointer. The outer edge of the clock contains a calibrated scale, which, as demonstrated here, can be rotated via the bezel ring for purposes of adjusting to zero, as you'll learn shortly. Within the main clock face on this model is a second clock-like unit known as the auxiliary gauge. The active part of a DTI is the plunger, which is free to move inward and outward. Linear movement of the plunger causes a resultant rotating movement of both the main scale pointer and the auxiliary gauge pointer. The pointer movement is achieved via very precise gearing within the instrument based upon rack and pinion principles. The plunger is designed to have a set travel. A protective cap covers the top of the plunger. The cap prevents dust and dirt from entering the delicate mechanism. The cap must always remain over the plunger rod. One further feature is this locking device known as a bezel lock screw. This, when tightened, prevents movement of the calibrated scale. We have looked at a typical DTI from a general point of view. After the break, we look at the principles of reading the instrument.